One thing that I wish would have come up on the exam were electron-deficient compounds. They seem like a interesting topic that not only do I wish was brought up on the exam, but I wish we had learned a little bit more about. I just thought this was a really interesting topic, and even though I still have questions about it, I wish it had come up on the exam, or at least a practice exam where we could have asked about it in class. I just didn't. We only really touched on them once in the lecture videos, so I wish we had talked a little bit more about them. Without further ado, let's jump on in. An electron-deficient compound is one in which there is an insufficient number of electrons to complete the octet of the central atom. These compounds contain insufficient numbers of electrons to form normal electron pair bonds between each pair of bonded atoms. This means that one atom will have an odd number of electrons on it. It is important to note that this is not the opposite of electron-rich, which is something you would see in an expanded octet, as electron-rich compounds have more than 8 electrons on the central atom, but will still have an even number of electrons. I wanted to put that in there because as I was looking for more information about this subject, I was, thinking of different questions to ask myself to, research to have in this video, and I thought what, was the opposite of electron-deficient atoms, so I thought, it would be electron-rich, but no, it is not, because it's a completely different meaning, completely different subject. Just wanted to include that to keep people from making the same mistakes and assumptions that I did. You can see electron deficiency occurring when you have an odd number of electrons, usually when you have an odd number of an atom with an odd number of valence electrons, which means if you have three nitrogens, that will multiply to 15, which gives you an odd number of electrons. This means that there will be one atom, the one that brought the odd number in the first place, with a central atom that will not satisfy the octet rule. An example of this would be NO2. So let's draw the Lewis structure for NO2. We have 5 valence electrons for nitrogen, plus 2 times 6 valence electrons for oxygen, and we add those together, and we get 17 valence electrons. Now let's draw the N with O's on the side of it, and draw one bond for each, and subtract the 4, which is what those bonds equal, from the 17, and we get 13 that we have to add in now. So we have, let's put dots on all of both of the oxygens, and so now we have the nitrogen in the middle with one dot on it. So both of the oxygens have 8, but the nitrogen only has 5. So in electron deficient cases, it will try to get as close to 8 as possible. So we will make one of the O's have a double bond, so we will erase these dots and move them to a double bond, giving the nitrogen 7, which is as close to 8 as possible. A similar example is ClO2. So let's draw the Lewis structure. We'll start with 7 valence electrons for chlorine and 2 times 6 valence electrons for oxygen. We'll add that together and we'll get 19 valence electrons. We'll do the same thing by drawing it out and subtracting the bonds, because there has to be at least one, from it to get 15 valence electrons, which we have to distribute all around. So let's give it to the oxygens, and now to the chlorine. And now, because chlorine already has 7, we don't have to do anything else. We don't have to make any double bonds. I wanted to have this in here because this will lead us to talking about ions and what electron deficiency means for ions. So ClO2 often forms ClO2 minus, which is the chloride ion, which we see quite a bit. When adding electrons, it is important to pay attention to whether or not it is an ion when you're given a problem or you're asked to draw a Lewis structure. Because electron-deficient compounds aren't very common, it is important to look back at the compound after counting to make sure you didn't miss anything. This is because ions will often form to avoid electron deficiency, which is something that one of the big questions that came up while I was kind of researching this topic. For example, we can see that if we add one electron to NO2, turning into NO2 minus, which is the nitrite ion, it goes from being electron deficient to all of the octets being satisfied just by adding that one electron. And we can see the same thing in the chloride ion by adding one electron to ClO2, which again changes it from being electron deficient to all octets being satisfied. So yeah, in making this, I not only learned more about the subject that was interesting, but if it were to come up in the future, I feel prepared to answer any questions that could come up on future quizzes or exams.